We have to mainly study three types of differential equations to solve them. First type is what is called as variable separable differential equations. Second is homogeneous differential equations, and third is linear differential equations. We will go through all these types one by one. So on high level, these are the three main categories of differential equations, and each of them has a different procedure to solve. So therefore we need to study them one by one. Now let us first go to the first category, that is variable separable differential equations. Now here, as the name suggests, variable separable means the term containing x and y can be separated and written on two sides of the equation, which can then be solved by integration. So in general, a variable separable differential equation looks like m dx plus n dy equal to 0, where m is some function of x and n is some function of y. So the basic idea is that we should be able to separate the terms in x and terms in y on two sides of the equation. Let's take an example to understand this. Now here we are given the equation e raised to x tan y dx plus 1 minus e raised to x whole into sec square y dy equal to 0. So now let us transfer the terms on two sides, and after that we can see that it's easy to separate the variables. So suppose we write e raised to x tan y dx. Now taking the second term on other side, we can change the sign in the bracket. So therefore we can write it as e raised to x minus 1 sec square y dy. Alright. So now here if we see, one y term is on this side and the other two y terms are on the right hand side. So we can bring tan y on this side and the term in x can be brought on the left hand side, so that the terms in x and y would get separated. Correct? So therefore let us do that. So therefore here we have e raised to x upon e raised to x minus 1 dx is equal to sec square y upon tan y dy. Right? Now to solve this means we have to obviously integrate. So therefore let us integrate both sides. So we have e raised to x upon e raised to x minus 1 dx is equal to integral of sec square y upon tan y dy. Now it's clear that in both sides we are seeing the numerator is the derivative of denominator. Correct? So therefore the integrals are of the form f dash of x upon f of x. So therefore the solution of that is log of the denominator. It is log of e raised to x minus 1 is equal to log of tan y. Now instead of writing the constant of integration as just c, it will be more convenient if we write it as log c. The simple reason is that now we can combine the logs and then remove them. So therefore this is equal to log of e raised to x minus 1 is equal to log of c tan y. So obviously removing the logs, we now have e raised to x minus 1 is equal to c tan y, where c is some arbitrary constant. So that is the solution of the differential equation. Now just one minor point here, it's not mandatory that you should add the constant term only on right hand side integral. We can very well add it on left hand side integral also. It will just appear in a different manner, but ultimately it is going to have some arbitrary constant on some side, either left hand side integral or right hand side integral. So this was the variable separable equation in which we could directly separate the two parts, that is in x and y. But let us see now a special case of this where the differential equations which is not directly